Okay, pre-calc guys. Last section of this chapter, P for prerequisites. Say that really fast. This last section is going to deal with solving inequalities, and there's going to be some absolute value ones, as you can see here. There are also going to be some quadratics, and you're also going to get to use your graphing calculator to solve some of these too. And we have a little physics at the end for you, so a little fun with that. First things first. Absolute value inequalities, there are two different problems you could have. This is the first one. Here's the second one. The first one is a less than or equal to. Anytime that you have a less than or equal to in an absolute value, that is going to turn into an and statement. So all that's going to happen is you're going to drop the brackets. You're going to put a negative 5 here. You're going to have a less than or equal to sign there. X plus 3 is without the brackets now. And then you're going to have a 5. So you're really going to have a compound inequality that you've created. Okay? Now, to solve that, we subtract 3 from all three sides. So this is negative 8, x in the middle, and then a 2 right there. So that's your answer. Now, if we were graphing it on a number line, okay, 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Now, because these are or equal to, we put brackets on either end. Okay? So, the less than or equal to, I should really do that, you're going to create an and statement. Okay? Now, if you have a greater than or equal to, what you are going to create is an or statement. Now, before you do that, you need to get the absolute value sign by itself. See, in the last problem, the absolute value was by itself. We didn't have to move anything. There wasn't any number in front or behind. Now we have a number behind. We have to minus 2 first. So absolute value 3 minus 2x greater than 3. Now we can make our or statement. So here's what happens. We're going to have two separate inequalities. One of them is going to be 3 minus 2x greater than 3. So it's going to look very similar to the original problem, just without the brackets. Or 3 minus 2x is less than negative 3. Okay? Because if you think about it, if what was inside the absolute value sign was less than negative 3, well, the absolute value of that would make it positive, and that number would be bigger than 3. So that's why we have to account for both. So you solve them separately. Negative 2x greater than 0, because if you subtract 3 to both sides. Now, one thing that I don't know if we really got into earlier is if you are dividing both sides of an inequality by a negative number, you got to switch that sign. So greater than becomes less than. Now, same thing over here. Minus 3 to both sides, but the difference now is you've got negative 6. So if you subtract 3 and subtract 3, okay, those go away, but negative 3 minus 3 is negative 6. Again, divide by a negative. Anytime you divide by a negative, you take that less than sign and you flip it. And this is actually positive 3. Okay? Now, if you were to graph this on a number line, and I'm going to have to make this small because of room. So that's 0 and that's 3. X less than 0, your parenthesis would open up to the left because that's less than. X greater than 3, you put a parenthesis on the 3 because there's no or equal to, so you use parentheses. Okay? So again, just to recap briefly, if you have a less than or equal to sign, you're going to make a compound inequality. It's an and statement. If you have a greater than or equal to, you are going to make two separate inequalities, solve each, and then you'll get your answer. Now, if they just give you a quadratic, okay, and they want to know, hey, what are our answers here? Couple ways you could do it. One, you could physically graph it on your graphing calculator. Okay? You could actually put into the y equals box, you could put this in. Now, when you go use your graphing calculator, okay, and I can show you guys this tomorrow in class, but really what you're doing is you've got to, there's like a, if you go to the far left of that window, okay, you've got, there's like a little box, and what you want is you want to choose the box that's shaded in like this. That's greater than. Okay, this lower part is less than. Okay, now you could do that and it'll shade it for you and everything's great. If you were to solve it algebraically, you'd have to factor that. So you'd have to do x minus 4, x plus 3 greater than 0. Okay, so again, you have two inequalities, x minus 4 greater than 0, x plus 3 greater than 0. So x is greater than 4, x is greater than negative 3. Okay. Now, you know, if you're graphing that, okay, if you're graphing that, actually, let's go back. Let's pretend that we didn't even solve that way. Okay. I prefer to use the calculator, but some of you are going to want to solve this out. Okay, so the graph goes through 4 and negative 3. Okay, and the vertex, if you guys remember this, minus b over 2a. Whoops, that's an x. So opposite of b is 1, 2 times a is 2. So I've got 1/2. Well, that works out just great, doesn't it? Now we got to do 1/2 squared minus, oh yeah, that's a disaster. Well, I would probably just say that, let's just say that your vertex is somewhere down, down there. So here's your parabola without getting too fancy with technical terms. Okay, so for all the x's bigger than 0 or bigger than negative 3, we shade in here. Okay, and by the way, that sign means this should actually be a dotted parabola. Okay, we'll get more into the algebraic stuff tomorrow, but you can but for right now, you can just graph it as an inequality in your calculator and it'll do it for you. Okay, the next slide, first thing we want to do, move the 20 over, get that to be less than or equal to 0. Okay, and then you can use your calculator again, and again, since this is or equal to, you're going to have a solid parabola. Okay, you'll have a solid parabola. And again, we can go over the algebraic stuff tomorrow. Here's an example right here of graphing. Okay. All right. Suppose an object is launched vertically from a point S0. So if it's S sub 0, we call it S0. From a point S0 feet above the ground with an initial velocity of V0 feet per second. The vertical position S in feet of the object at t seconds after it is launched is, and here's our formula. Okay. A projectile is launched straight up from ground level with an initial velocity of 288 feet per second. When will the projectile's height above ground be 1,152 feet? Now, you got to just go back here. All right, this is S. Okay, so 1152 equals negative 16 t squared, because it says when will the projectile's height. So when means time, so you're finding the time. Plus, now V0 is the initial velocity. Well, it says the initial velocity is 288. Okay? Now, it says suppose an object is launched vertically from a point S0 feet above the ground. Well, it says the projectile is launched straight up from ground level. Well, how many feet is ground level? 0. So S0 in this case would be 0. because the initial position was on the ground. So what you would do is you would subtract 1152 to both sides. So it's going to look like this. Now there's a couple ways you could approach this, guys. I'm just going to be honest, you could divide that all out. Okay, so if you had, let's see, 0 equals negative 16t squared plus 288t minus 1152. You could find a common factor, okay, and divide that out. So, I mean, if you divided everything, I mean, you could obviously divide by 2. Guessing you could divide by 4. Just kind of looking at it. Let's just do that and see what happens. Because those are big numbers. We want to try to make those smaller if we can. That's 72t. Sometimes it's hard to do math in your head, kids. But we are professionals. So let's see. That's 288. I hope that's right. Okay. And now you could probably divide by 4 again. And this time I just divide by negative 4 to get rid of this negative. So 0 equals t squared minus 18t plus 72. Now that you have that, factor it. So two numbers that multiply to that multiply to 72 and add to negative 18. Well, they're both negative. 12 and 6. Now this is interesting. Hopefully I didn't make an arithmetic mistake here. Whoops. When you go to solve each, so when you go to solve each factor, you get 12 and 6. Oh, that's interesting. Where did we make the mistake? Because we have 2 answers and we have to figure out which one is correct. Well, my guess, if I were to hazard a guess, would be to take 12, plug it into the original equation. So you've got t equals 12 and t equals 6, unless I made an arithmetic mistake, which is always possible. Okay. I would put 12 in for t and find out if that works, and then put in 6 and see if that works. My guess is one of these 2 answers is not going to work. Okay. Now, the last part, when it says, when will the projectile's height above ground be at least 1,152 feet? At least means greater than or equal to. So it's the same problem. Okay? Same problem. You don't even really need to work anything out. You already have the answers. Okay? So now just apply it to the inequality. Okay? All right, we can go over this a little bit more in class, but I wanted to just give you a general idea with the absolute value inequalities, graphing the inequalities, the quadratic inequalities in your calculator. You can easily figure that out. We can talk more about the algebraic part tomorrow, but this was just a little introduction just to get you guys started. So we'll see you guys tomorrow, and have a good night.